Welcome to qnawire.
Welcome to the problem number 31.28. This is chapter 31, alternating current. So in this question we have a LCR circuit. So this is our resistance, this is our capacitance, and this is our inductor. And this is being connected to an AC source, and these are the parameters given to our question. So these are the parameters related to this circuit. So we will use this information to find out all the parts of this question. So this question has D paths, I mean four paths, so A, B, C, D. So we will go one by one to find out the answers. So let's do the part A. So first we have the impedance, which is Z, which is dependent on this factor. So we need to find out the which condition which makes the Z minimum. So Z is minimum when XC is equals to XL, which is the resonant condition or resonant frequency. So we have X equals to XL, which means omega is equals to 1 over root under LC. So at this condition, we will have Z minimum. So looking at this one, definitely, so this is a number, which is a positive number. This is also a positive number. So both add, that means we have to this one cannot be negative 0, and this one can be 0 only if and only if X is equals to XL, and that makes this condition. So Z is minimum when XC equals to XL. So we have omega equals to 1 over under root of L, which is 8 into 10 raised to minus 3 Henry, using this value here, and C is over 12.5 into 10 raised to minus 6. So this comes out to be 3162 radian per second. So we have Z equals to R, which is equals to 175 ohm. And omega is equals to 3162 radian per second. Now we go to the B part. So we need to find out the current amplitude, so which is equals to I equals to V over Z. So we have Z equals to 175 ohm. So we have 25 over 175 equals to 0.143 ampere. Now we go to the C part. So we have I equals to I cos omega t, which is equals to I over 2. So this is the condition given. So we have cos omega t equals to half. So we need to find out the time, which is, so we have omega t equals to pi over 3, because this is the only condition which satisfy we here. So we have this one omega, so we can find out t here. So t comes out to be pi over 3 times 3162. So gives us the time at which the current has half amplitude of the current. So this is seconds. All right, so we are done with the part C, but we have to find more information. So we have now V equals to V cos omega t plus phi. So we have 10 phi, which is equals to xc minus L xl, or minus over R. So this comes out to be 0 because x is our xl. So using this condition here, so this comes out to be 0. That means phi is equals to 0. So therefore V is equals to V cos omega t. So using the same values here, so this comes out 25 times 1 over 2. So this gives us 12.5 volt. Now we need to find out the voltage across resistance R, which is VR. So this is Ri, which is equals to 175, and I is our I over 2, which is the current amplitude. So we have equals to 175 over 2. Current amplitude is our 0.143. So this comes out to be 12.5 volt. Now coming to the VC. So VC is VC. So this is the instantaneous and this is the amplitude. So we have cos omega t minus 90, since 90 is the phase difference between the resistance voltage and capacitance voltage. So we have IXC cos omega t minus 90. So putting all this value here, so we have 0.143, and X is our 1 over omega c, which is 3162 times 12.5 microfarad, which is 10 to the minus 6 farad, times cos 60 minus 90. So this gives us equals to 3.13 volts. So this is the instantaneous voltage across the capacitance. Now we go to the next step. So we have VL, which is equals to voltage amplitude across inductor. So we have cos omega t plus 90. So this is the phase difference between the voltage across the inductance with respect to the voltage across the resistance, and the phase difference is 90. So we have IXL cos omega t plus 90. So putting all this value here, so this comes out to minus 3.13 volt. So we are done with the part C. Now we go to the part D. So we have VL plus VR plus VC, which is equals to 12.5 plus 3.13 minus 3.13, which is comes out to be 12.5, and which is the source voltage at that time. So that's your answer for this question. Thank you for watching the video.